Hi everyone. So today our presentation is not about fancy tech. It's not about JS. It's pretty simple. We'll just talk about life. When we value life, most of the time, we'll talk about money, health, and happiness. And this is the reason why we want to do this project. So for our motivation, our goal is we want to know if can money buy happiness or if health is more important for happiness. So we'll be doing an analysis on money versus happiness and health versus happiness. So for our data source, we'll be getting the data from Kaggle and the World Bank. And the variable that we'll be using will be happiness score from the Kaggle, the GDP per capita with our money from the World Bank, and then the life expectancy with the health also from the World Bank. And then for the original data, happiness score data by Kaggle is from the World Happiness Report.
So the method we are using is least square regression, and we are implementing linear, quadratic, and cubic regression for the project. For the programming language, we're actually using SAS and Python to do the programming. And the reason we are using SAS is because we get the data from different sources. We have 3 different data sets, and SAS can help us to manage the data easier. And it also has some built-in SQL query inside SAS, which can help us to merge the 3 data sets into 1 data set for easier managing. While for the Python, it's pretty simple. We use it to do the computation for our regression model. This is the sample layout of our data set after doing the SAS pre-processing. So after merging the 3 data set into 1 data set. And initially we have 3 different data sets. For the World Happiness Report, it consists of country happiness at year, which is the first, the second, and the 5th column. Well, for the World Bank data, one is for the GDP per capita. So it consists of country, GDP per capita at year, which is the first, the third, and the 5th column. The other one for World Bank is the life expectancy, which is the first, the 4th, and the 5th column. So after merging these 3 data sets into 1 data set, it will become something like this, and the data is pretty straightforward. So let's say if you want to see the GDP per capita for Argentina for 2017, it is about 14,000. For Australia, it's about 54,000. If you want to see a life expectancy for Argentina, is about 76, and for Australia, is about 82. And we are actually doing the data from 2015 to 2019. So we actually have 5 years data set, and for each year, we have about 150 countries. So 150 times 5, we have about 700 to 800 observations in total for our data set. And if you look at the second column, which is the happiness, is actually a score ranging from 0 to 10, which 0 means the saddest and 10 means the most happiest. This is the brief introduction of what we have done in our SAS. So first, because we get the data from 3 different data sets, and some of the country names does not share exactly the same name, like Trinidad and Tobago. Some data set use %, the other data set use AND, or like Democratic Republic of Congo. Some data set only use Rep of Congo, so we have to change them to be consistent. Same case for Venezuela, RB, so we just make it into something as simple as just Venezuela. So after making all these country names to be consistent, we join them using the same country name and the year to using the SQL query to join them to become a single data set, look like this one. And yeah, so this is how we get our single data set, and use these data sets to be the input for our Python. And also we remove the observations that contains of null value as well before inputting into the Python.
So for Python, we'll be implement the least square regression method for the linear and quadratic and cubic, and then we will be normalizing the GDP per capita with the money, and then the life expectancy with the health, because money and health have different range, and then the GDP is range from several hundred to 85,000, and then for the health is range from 55 to 85. So we'll be normalizing them to 0 to 1. And then there's the formula for the normalizing, which the x minus minimum, and then divided by max minus minimum. And then we'll be doing two regression, which the first regression is the GDP per capita for x-axis, and then the happiness for y-axis. And then the second regression will be the life expectancy for x-axis and the happiness for y-axis. And then we'll be generate the curve, the two of the curve to show the relationship.
This is our implementation result. And because we actually do it from 2015 and 2019, so we have 5-year data. But right now we are just going to show you one of the year, which is 2017, which is shown in this slide. So after implementing linear, quadratic, and cubic regression, we can see that for linear regression, it's pretty straightforward. So it has a positive relationship, but it does not capture the data very well. While for the quadratic regression, you can see that it's actually a concave downward graph. You can either see it from the graph or from the coefficient of x squared, which is a negative value. So it's a downward concave curve. And it's a downward concave, so it means that the rate of increase is actually decreasing along the line, which simply put, we can say that the money can buy less and less happiness when money increases. And we also notice that the optimal point of quadratic regression is at about 0.6, and then it starts to decrease after that, which is debatable. Means that it doesn't mean that it's going to decrease after 0.6. It's just simply the characteristic of the quadratic equation, which has a symmetric shape between the optimum point. So it does not mean that it will decrease. Also, we can see that there are a lot less data point at the right hand side. So it's just a characteristics of quadratic equation, but we can see that it's still a downward concave curve. Well, for the cubic regression, we can see that it has a sharp increase at the beginning, but tend to cap at about 7 and being flat going forward. So this is the implementation for all 5 years. And you can see that there, the trends actually share very similar characteristics across the year. So again, the linear regression has a positive relationship. And for the quadratic equation, it's still a downward concave for all the years, and also have an optimal point at about 0.6. While for the cubic regression, you can see that it's still a sharp increase at the beginning and then tend to be flat at about 7. And when you see from our graph, you might notice that we actually have a lot more data sets, data point from 0 to 0.2. And then we have a lot less, which is about 5 to 10 observations only, larger than 0.5. So we are actually aware and worrying about the outliers as well. And that's why we implement the data without outliers. So outliers, very simple. The Q1 minus 1.5 IQR to Q3 plus 1.5 IQR. So it actually removed those high income countries in our data set. And you can see that this time the trend are actually still similar, although the regular regression is still a positive relationship, but this time it tends to capture the data a little bit better. While for the quadratic one, is still a downward concave curve, but this time the optimum point is about 0.7, 0.8. While for the cubic, is still a very similar trend, tend to increase at a sharp increase at the beginning and then flat at a certain point. But this time it's at 6 instead of 7, which is reasonable because we have already removed those high income countries.
So for the health versus happiness graph, we also use the data from 2017 to show the linear, quadratic, and cubic function. Even though the cubic function is curving downward near 0.8, which is the green line, and then but all of the function still has an increased relationship for health versus happiness. And then this is the graph for from 2015 to 2019. And then as you can see, all the graph is pretty similar as well. And then you can see that the curve keep increasing with respect to health rather than money, which is kept at a certain level. So for a result, or for GDP per capita with the money versus happiness graph, and then you can see from 2015 to 2019, we place the value inside this table for an easier view. As you can see, for the linear, quadratic, cubic MSE, the cubic MSE has a lower value, which means that it provides more accurate result. For linear regression, it has the A1 which is the 2.827, and then A0 is the 4.369. From left to right is the A1, A0, and then for quadratic regression also the same is from left to right, which is the A2, A1, A0, and then cubic regression also A4, A3, A2, A1, A0 from left to right. This is all applied the same from 2015 to 2019. And then for life expectancy with the health versus happiness, as you can see for the cubic MSE and the quadratic MSE, it will provide similar result because of their similar MSE value. And then for linear regression, quadratic regression, and cubic regression, also from left to right, we reach the A3, A2, A1, A0 for year 2015 to 2019. Let's follow the graph from before as well.
So conclusion, yes, money can buy happiness, but it will cap at a certain level after a spike increase at the beginning. And then after that, money would only have little to no impact on happiness. And on the other hand, we see that happiness has a direct correlation with health. And instead of capping at a certain point, it actually just keep increasing and have a more positive relationship compared to money and happiness. So we would say both money and health are important to happiness, but money would only help to a certain extent, while health can bring more happiness going forward and in the long term. So for the future work, first, we are aware that our data is based on country level instead of individual basis, which is something quite debatable because we might question that whether everyone in the country will share the same happiness level. And then if possible, we can maybe analyze based on the state level or different income tax group to see a relationship, because this might reflect the relationship more from an individual basis. While for the happiness measurement, we also know that it's pretty hard to justify the happiness. It's a very subjective kind of things. World Happiness Report actually doing the survey and then have some back-end calculations to come up with the happiness measurement, but it does not simply mean that it's the best indicator in measuring happiness. Some other variables like culture or social support, which is something that cannot be easily reflected on the data. For the GDP per capita, we are also aware that it does not fully represent money, because let's say if we have two individuals sharing the same level in income level, and then but the first person prefer to save money and the second person prefer to spending money, buy things, we would say that maybe for the first person, saving money might bring more happiness to them, while for the second person, spending money might bring more happiness to them. This is something that GDP per capita cannot capture. The last point about life expectancy could not solely represent health. So it's very simple. So we are saying that we might have a case that someone that live longer, but he or she has a lot of illness along the time. So this does not simply mean healthy as well. That's all for our presentation. Thank you.